Yeah, yeah. Somebody was saying that there is a basis of everything. So, something. I am not related to this data science, so I cannot comment on that. Yeah, even I felt it is outdated, but people are saying that's the, I mean, the base of things. So they are. Mhm. Okay, I think four people have come. Hi Satish and hi Milind. Yes. Yeah, I think we can start it here. So what the plan is to go through the questions of the midsem, and I hired a tutor and he taught me something which was interesting and which was simple. So I thought of sharing it. This is already done last week also, so that's maybe the reason why people have not joined. Anyway, let's go through this. This is the last week's session recording is there, but anyway we will do it once again. So the first question is 2020 11th. Okay, so the question is, consider the following DNN deep neural network for an image classification for a data set consisting of RBG image of size 32 by 32. And this is the Keras codes. Anyone here who knows the Keras codes? Oh, okay, fine. No issue. So this is the Keras code, and here they mention model sequential layer 1. You know this layers, no? In the neural network we have a dense input layer, then output layer. I mean the hidden layer, then the output layer. No, these things we know, and there is an activation in the hidden layer. And this already we have learned in the ML, and everyone can recollect it or what? Yeah. Okay, fine, good. So the first layer input, there's an input layer, so this is directly connected to the input layer, and then we have this is the hidden layer 1, sorry, and this hidden layer 2, and here, yeah. So first one, this first value denotes this is the syntax of the command. The first value denotes the number of neurons. So this is the first hidden layer. That layer 1 is the first hidden layer. In before we have an input layer which is automatically taking the view. And layer 2 we have 40 neurons, and layer 3 we have 30 neurons. And each layer we will be having an activation function. Here we are using a ReLU activation function. So whatever this ones we will be later knowing it, but for the time being let's go through the question and try to understand what the stuff is. Here there is an input shape they mentioned, and it is star star A, and here star star B and star star C. This stars means it's unknown, so we have to find this value. And then we have the final layer is the output layer. So there is a activation is they have mentioned C. Then compare optimizer. SGD is this one, I mean stochastic gradient descent. Then we have to find the loss function for this, and this is commonly used something. Now the first question is, what is the input shape of A star star in the layer 1? So this is a layer 1, right? So input of this layer should be the input layer, and we need to find the input layer. What is the shape of the input layer? Before going deep, let's go through they have mentioned it's a RGB image, right? So we can learn something about the image. I just added few slides for that. So this is a black and white image, 7 by 7 pixel. 1 2 3 4 5 6 7, and here 1 2 3 4. So it's 7 rows and 7 columns. I think everyone can appreciate this one, right? Is okay? Yeah, Praveena and Milind. Yeah. Okay. So here we have the black and white image, and how is the black and white done? 0 for black and white for 1. So all the white ones are marked as 1, and all the black ones are marked as 0. And this is taken as a matrix. So here you can see we have put the commas instead of the boxes, and we have put a matrix symbol, right? So all these are in the matrix from rows and columns in the matrix. So this black and white 7 by 7 pixel is a demo for understanding the black and white picture. Now let's go to the grayscale. So this 7 by 7 grayscale pic, so here each value, here we have 0 for black and 1 for white, so there is only one bit required. No? Here we have it's a grayscale, so we have a shades of black to white. So here we have white and here we have black. So if you see this white is 255 they marked, and black is 0, so all the shades will be in between this range 0 to 255. So each row and column, that square will be having 0 to 255 one of the values. So here these shades are marked with the values 255 for the white and 0 for the black, and all other shades are marked accordingly, and then this is taken as a matrix. So for each value, here in the black and white we had only 1 and 0, so here we have values 0 to 8, that means almost like 8 bit or something, right? 8 bit. Is this clear, this grayscale thing? Yeah, Praveena? Oh, okay, fine. So let's go to the RGB. So our question is related to RGB. I just gave an introduction on this one. So this RGB, if you see, each box will be having RGB inside it. So that means each has to give values like this. See 100. There will be 3 values: one for R, one for G, and one for blue. So it will be like 3 layers, like one after the other. So this is the RG. In the grayscale we had a single value, 0 to 255 representing one of the value, but here we have 3 values to represent each box, each point, each row and column. We are representing by 3 values. So it's a 3-dimensional matrix. Is this understood? Okay, fine. So then we have 32 by 32 pixel means 32 rows and 32 columns, and then it's an RGB means it will be having 3 layers, like, so it will be 32 into 32 into 32. This will be the shape, and when it's flattened we can write, multiply by this one, just multiply it, and we can write 3072 comma. Yeah, see, in the RGB we have, sorry, in the black and white we have only one bit, right? So we can write 7 by 7. Here we have 7 pixels on the left, and on the columns, and 7 on the row. So it's 7 by 7, right? And each one is denoted by 1 and 0, 1 or 0. Here we have a value 0 to 255, but only one value is there. So again this will be 7 by 7 matrix. But when you come to here, we have each color is represented by a particular ratio of green and a ratio of blue and ratio of red, right? Exactly. Yeah, exactly. That's the correct word. Yeah, pixel is represented by 3 values of each value of RGB, right? So each pixel will be represented by 3 values. Here each pixel is represented by 1 value. So here we have 3 values. So it will be like layers, no? 3 layers. So so there will be like 3 layers. So that's why we are putting 3. So now 3 dimension now. Is it clear? Exactly. Yeah. Okay. He is confused with why 32. Yeah, 32 is the actually our question. In the question they mentioned RGB image size of 32 by 32. So I took this example as just as an example or demo. I got it from somewhere for the 7 by 7. So in the answer we have 32 by 32. Yeah. If it's a 7 by 7, it will be 7 into 7 into 3. Okay. Oh, thanks Praveena for helping you. So yeah, of course, yeah, you can jump in anytime. That will be a lifesaver for me also. Okay, now okay, the first question is answered now. What is the image size of the input, right? So that was a question. What is the size of the input? What is the shape of the A in the layer 1? So this is the input layer, and the shape is 32 into 32 into 3. So this answer is clear, and we can go forward with the next question, right? Fine. So let's go to the B. What will be the value of B activation function, and C and the loss D if the total number of classes in the data set is 2? See, the data set 2, they are asking this one. Okay, so here we have A, we already got. Then in the last layer we are adding B. We know the B is the number of neurons, and that's the first parameter of the this function. And then we have the activation. Here we have ReLU activation. You know ReLU, what is ReLU and all, right? Yeah, activation function, yeah. So in the C we need to find what is activation function, and loss function also we need to find. So first of all, they have mentioned the classes in the data set. The classes in the data set, so we have only 2 classes in the data set as per this question. In that way the output will be only 2, right? One of the 2 classes, right? Right? The output has to be 2 only, yeah. So number of neurons required is 2, right? 2 or 1? How many neurons are required to show 0 and 1? Exactly, yeah. So they have mentioned the answer as 1 here. That is given by university. So B we got as 1. Now the activation function. So activation, how will you get 0 and 1? The best thing is sigmoid, right? We have learned already sigmoid. If you give anything to sigmoid, the output will be 0 and 1, right? ReLU is linear, right? It will be 0 to 1, but in between it will be having values. Yeah, and there is one more. One more function is the activation is there. That's tan h. No, tan h will be like -1 to +1. Yeah. So yeah. No, this is not an input layer. This is not this is an input. This is a hidden layer actually. It's a dense layer. No, it's a hidden layer. So input layer is before that. So that's why it's mentioned input shape to this one. Yeah. As per my understanding, this should be the hidden layer. First hidden layer is having 50 neurons, and the input layer will be different because input layer we are having the same like this one. Yeah, these 3 should be hidden, and the last one will be the output. No, this one, the 4th one. Yeah, that will be the output. Yeah. Because here we are giving 1 neuron to get 1 and 0, 2 outputs, and activation is sigmoid, so they have given the answer as sigmoid. And then we have the loss function. We have several loss functions. Okay, let's just go through this. I just added some clips here for detailed understanding. So layer 4 is the last layer as per the code, which means the output layer. Sigmoid provides just 2 outputs, 0 or 1. This is Keras code. Different activation functions are available here at Keras page. If you go to this page, you will find a lot of activations. Maybe you want to go or what, and see what are the different activation available. Yeah. So layer activation functions. You see, so available activation functions ReLU. Yeah, we have this ReLU. Then sigmoid. And this Keras, actually Keras web page. Okay, softmax. We will go to softmax soon. There's an we need to go. soft plus and soft sine tan h. Yeah, this is what we are discussing. Then celu is there, ilu, exponential, and then we can create some custom things. So here the most important ones are softmax, and we'll go to softmax soon. And then sigmoid is another for 1 and 0, or what you say, binary classification. We use sigmoid mostly. And then ReLU is for the hidden layers. Usually we use ReLU in the hidden layers. I mean the hidden layers are used this function usually. So that is about activation. And then we have BC. The first argument denotes the number of nodes is this one, first argument. As per question B1, we have only two outputs. A single node with sigmoid activation can provide two outputs. Hence the answer is B is equal to 1 and C is equal to sigmoid. Yeah, this is a sigmoid function. Then the loss function options D for the binary classification are given here. Let's try that one also. So how to choose loss functions? Yeah, so we have the binary. This is a binary classification, right? So we have these three types: binary cross entropy, hinge loss, and squared hinge loss. Now let's see again. So yeah, it's already given here, the screenshot. As for this, the common is binary cross entropy, while hinge and square hinge is for SVMs, support vector machines. So commonly used for sigmoid and for binary classification is sigmoid activation and binary cross entropy as a loss function. Cross entropy is a default loss function to use for binary classification problem. It is intended for use with binary classification where the target values are set to 0 and 1. Mathematically, it is the preferred loss function under the inference network for maximum likelihood. I don't know what is this one. It is a loss function to be evaluated first and only changed if you have a good reason. So this is like a permanent thing. Everywhere you will be using this one for the binary classification, unless there is a reason to change. Cross entropy will calculate a score that summarizes the average difference between the actual and predicted probability distribution for predicting class 1. The score is minimized and a perfect cross entropy value is 0. Cross entropy can be specified as a loss function in case of specifying when comparing the models. So take it as a rule. For image binary classification DNN, the best loss function is binary cross entropy. So this is my take on this. Hence answer for the where output is only 2, model dot add. One is the neuron, activation is sigmoid, and this is given in the question. Loss is binary cross entropy. This is also given in the question. So we completed the B. Is this clear? Yeah. This hinge and squared hinge, they are already mentioned, it's for SVM, and we are not using SVM here, no? I mean, that's what mentioned in this link. So yeah, for the time being, I think this is good enough to go, right? And as we learned from the, so there will be some sessions by others, and in this university also will be taking the session. That time we will have more understanding. So this is like a iteration. This is the first time. Exactly. Yeah. Right. Yeah. If we are lucky enough, we can go through. We will be able to go through their lectures and understand more. Yeah. Yeah, I don't know about how was SEA. I took the easy thing in even that I didn't go through properly. So let's try to This time let's try to answer the questions, and at least we will iterate through these questions again and again, no, like one time we go through 3 question papers, then again we can start it, so that time we will have more understanding, right? Last time I thought like that and bought the the 2 books, one statistics and one ML. Both are laying there. I didn't check it actually. Hmm. Okay, Praveena, you do one thing, no? You can maybe learn this NLP or big data or SP or something, and you can take some session per week, no? Mm-hmm. Here we have so many question papers available. But are you sure these options are available? But what I heard is only one elective is available, and we have to choose between NLP and IR. Yeah, SPA, big data, and DL. This is what I heard from the seniors. I don't know. Anyway, we can't take a select in between, no. If they are forcing us, then I don't know what to do. Personally, I didn't like this big data stuff, but I think yeah, but that's why we closed that discussion, because finally we came to know that from one of the seniors that only one elective is available, and even that we are not sure right now. So let them speak it out, then we will take it up the discussion. Yeah. There's no. Maybe, yeah, like when we polled, no, for IR only 2 people were there. so so similarly for there are graph and PGM, as you said, only few people will be there, and I don't know, they will take sessions like that, no. Yeah, anyway, let's wait for their announcement, no. We need not speculate it, no. Just I don't know. You have to ask them only, no? No, I was in the group and ML group was good. That exam, so many people were posting the answers. So what I did is I meditated and I looked at the breath and and it was very relaxed. No, and that it took around 90 minutes for me to cool down. And then slowly I started writing, and then boom, after the fifth question, it got auto submitted. Yeah, but I was very composed. No, I was very relaxed actually. Okay. Why you didn't write then? Yeah, because time. Okay, because you are doing by yourself. That's really kudos. Yeah. Okay, nice. So this, this Sumil, no, he is an expert. So what he is doing is he is creating a code and just copy pasting. He got today he explained that he got 92 for ML, I think. And that we had to ask him only. Maybe it depends on person to person, right? So we have to ask maybe. Yeah, nice. Good. Anyway, let's yeah. You are asking me? Yeah, I got I think 30. Hmm. 40 out of 40. Wonderful. Yeah. Congrats. So this ISM you did by yourself, right? Wonderful. Okay, okay. So, sorry to interrupt, but how you are able to learn this? I mean, the ISL so well. You are from statistics background, or you are MTech, or you are a PhD, or what? Hmm. Hmm. Okay. So I was asking whether you are a double MTech or a double PhD or something, or. Ah, see, microelectronics. Wow. Mm-hmm. Wonderful, yeah. Oh, wonderful. So yeah, so nice to meet you, Praveena. Actually, last 2 days back, also I met some other lady. I think Revati. She was a PhD actually. So I was really surprised. Yeah. Ah, okay. So you could have gone to PhD directly, but you came here now. Okay, I am also planning to go for PhD after this, but I'm not sure I'll be going for. Uh, mm, mm. Yeah, but see, studying is good, but we should make use of the studies. You have done LLB, you have done MTech microelectronics, but then are you in those domains, or you are separate, different, working on that? Hmm. Mm-hmm. Okay. Yeah, good, yeah. Mm-hmm. Mm-hmm. Anyway, very nice, yeah. Nice to hear those, yeah. Mm-hmm. Mm. Okay, great, yeah. Mm. I work in IPTV as a broadcast engineer in Sharjah. Yeah. Mm-hmm. Okay. It's 8:20 here. That means 9:50 there, no? Hmm. Okay, fine. Maybe 10 o'clock. Anjani will be taking a session. I hope. Let I have requested him to take the variance, the bias and variance underfitting, overfitting stuff, no? So the variance thing, I have a doubt, so he told he will clarify that one. Yeah. Anyway, let's go through this for the 10 minutes, and then maybe if he's taken, then we can wind up that time. So the next question is, what will be the same question is repeated with the output, you see the total number of classes in the dataset is 10. So what will be the value of B, that is the number of neurons, and then C, that is the activation, and D, the loss function, if the total number of classes in the dataset is 10. That means what? So we need to have it's a classification problem, no? You have a, so how many neurons will be required if we need 10 output classes? No, actually each one will be each neuron will be 1 and 0 for a particular class, right? So layer 4 is the last layer as per the curve, which means output layer. In this question we have 10 outputs, hence a sigmoid can't be used. Sigmoid is a single output, no? And then we have using commonly used activator function is softmax as mentioned here. So let's go to that part. Okay, meantime we can come back here. That's again we need to decode, no? Yeah, because output is, see, if you have 10 neurons, each one will have, for example, if you are having cat, mouse, or cat and dog issue, no? So you are putting the into the input those images, and output, if you have 10 different cat, dog, man, woman, like that, 10 options, 10 classes, then it will show a probability like 0.8, 0.9, 0.7, 0.8 for each of the output, right? So this is the this is the ReLU function or something will be there to show this sort of probability. but then output again, if you see, it's having, if you add it, it won't be 1, right? So let's read this one. The output of the sigmoid function was the range of 0 to 1, which can be thought of as probability, but this function faces certain problems. Let's suppose we have 5 output values, 0.8 like this respectively. How can we move forward with it? We can't. The above values don't make sense, as the sum of all the class output probabilities should be equal to 1. So here we don't have 1 total. You see, the softmax function is described as a combination of multiple sigmoids. It calculates the relative probabilities. Similar to the sigmoid logistic activation function, the softmax function returns the probability of each class. It is most commonly used activation function for the last layer of the neural network in the case of multiclass. So sigmoid, the softmax is the function that is generally used for the categorical classification problem, where we have more than one, like not a binary one. So that is something that is fixed, like it's the most often softmax is used. And now we need to know what is softmax. Softmax is something like see, these are hidden layers. Okay, then we have the logit, right? So in the logit layers is here they have mentioned apple, beer, candy, yes, no, dog, yes or no. So these logits will give this output like this. So what, and then we have a softmax function over it. So what does softmax do is the output will be 0 to 1 total. When you add it, it will be 0. Add it, it will be returning a 1. There's a probability is maximum 1, no? So it will be equal to 1. All the probabilities should be equal to 1. So how you generate this? Is it clear? Like this one is clear. Each one is having the probability output of this numbers. Is this clear? Yeah, exactly. That's the reason we are using this function, softmax. So in this softmax function, you have this equation: exponential of zi divided by summing of exponential of zj. So zj is all these are summed up separately with the exponential, and then we are dividing this with with this one. The reason is mentioned below. Yeah, let's try here. The logics are interpreted to be normalized, noted normalized, or noted predictions or output. This can give result, but we don't normally stop with logics because interpreting the raw values is not easy. Seems output of logics may sum up to more than 1. This is our issue. To normalize, we use the softmax, which has exponential function as discussed above, which overcomes the overwhelming constant issue. Yeah, constant issue. Okay, when the numbers are high but difference is low. So this is what they are trying to make us understand here. For example, what happens if the output is 10 and now 11? Now the softmax gives 1 by 3 and 2 by 3. The squared version gives approximately 0.45 and 0. See, we are comparing the softmax function with the squared version. In the squared version, we are getting output like 0.45 and 0, which is difference is quite less. But in the softmax, we are getting 1 by 3 and 2 by 3. Here the difference is quite high. For the same input, we get a bigger difference. Like if the output is 100 and 101, softmax would still give 1 by 3 and 2 by 3, but the squared version would give 0.495 and 0.505. Is this clear? From this example, it is clear that softmax only cares about the difference, whereas the squared version cares about the location. So this is the most important part of yeah, maybe Praveena, did you get it? Yeah, would you like to explain then? Exactly. And in the softmax, there is see, suppose 100 and 101, whereas 10 and 11. In this, the difference is 1. In this also, the difference is 1, right? Satish? Yeah. So when you are using a generic function, then a difference between this is won't be much. So the different, so you will be getting something like this probabilities, which is very near to each other. But in the softmax, it removes the constant. Here the 100 is a constant, so it is 0 and 1. So then there is a big difference. So that's why it gets 1 by 3 and 2 by 3. So 1 by 3 is like 0.3 and 2 by 3 is 0.6. So there's a big difference. So that's why it's mentioned. The softmax only cares about the difference, whereas the squared version or the other option cares about the location. Like if it is 1000 and 1001, it will be much more lower, this one. And if it is 0 and 1, it will be very big, right? Hope you got it. Fine. Now the options like B is a number of output, right? So in this one, B is the number of neurons. So if we have 10 data set, 10 classes, then B has to be 10. Activation we got, it's a softmax. And the loss. Now the loss is categorical close entropy. This is the default option used for the loss function in the classification issues, multi-class issues. Yeah. So binary, we have binary close entropy, and here we have more than 2 outputs. We have categorical close entropy. So if you want to go more deep, it's here mentioned probabilistic losses, binary close entropy. We'll be going through this when this Keras, 2-3 toppers have told that they will take the Keras session, so maybe we can go through this again on categorical close entropy, then sparse categorical close entropy, Poisson class, binary class entropy. This we already used there. Categorical, yes, this one we are using now. Sparse categorical. Yeah. So that's about. So is that clear? This one. Logits is something used in the output. Output layer. That's it's creating the probability. Yeah. That's all. In this point, I can take. Maybe if you are interested, you can just have a look and come and in the next session you can explain to us. Yeah. So this that's about the logits. Output layer. When there's multiple, this one we have logits, and then we have a function over it, softmax. Yeah, that could be, yes, right. Yeah. Yes, so I'm not sure this is going to end or not. Anyway, let's go through this. Yeah, so then we have the if it ends, we have to relog. Next question is a little more little interesting. What will be the total number of parameters in a layer 1, layer 2 and layer 3? If I drop out layer, okay, first let's go through this question. What is the parameter? What are the number of parameters? See, what are the number of parameters? Anyone can guess what are the number of parameters, or what is a parameter? Yeah, right, that's right. Weight is one thing. Then second one, it's a bias. Yeah, bias and the weight. No, it's like, see, in the y is equal to wx plus b, you have weight and the bias, right? So it's these two are the parameters. Just actually the model, what the model is doing is find the proper bias and proper weight, right? Right? Yeah, there will be different this ones, but anyway, this has to be weight of this is the weight, right? No, see, in the neurons, basically, we will be using the bias and the weights. These two are the most critical things. Okay, so exactly. Yeah. So we have the bias and the weight. This is the system is going to change the bias and weights and optimize it for the output, getting the proper output. This is basically the neuron, right? What we are expecting from the neuron. Yeah. So with that understanding, if you see how many weights are there, this is a dense network means what each input hidden layer is connected to the next layer. For example, this is the input layer. This input layer is connected to all the hidden layers, right? First hidden layer, right? And each hidden layer is connected to all the okay. So we will just check it out. So how many weights will be there for this? It depends on the number of input layers. No, for each neuron in the hidden layer, we will have the same. It will be equal to. It will be connected to all the inputs. So inputs is like 3072. This we got already, right? 32 into 32 into what? 3. That's the image, no? RGB image of 32 by 32 pixel, right? That's the input. Is it clear? 3072 is clear? Fine. I hope it is clear. No? See, we are connecting it. All the inputs are connected to the hidden layer, and input is of the shape 3072. 32 into 32 into 3. So many inputs are there, and this is connected. Each of them are connected to the hidden layers. So that has to be multiplied by the hidden layer, first hidden layer. And what is the first hidden layer? If you check it here, yeah, first hidden layer is 50. So we are multiplying the input with 50, and then each hidden layer is first hidden layer is having its own bias. So we have to add 50 again. So we got this number. I hope it is clear. Any doubt? Yeah. So we have 50 bias. Yeah, each neuron is having one bias, no? Yeah. So you can, it's mentioned here, no, bias. Each one is having a bias. So what they have represented as like this. So this is bias 1, this is bias 2, this is bias 3, this is bias 4. We have 50 neurons, hence we have 50 bias. Bias is equal to the number of neurons that layer is having. And then the confusion is here actually, because in the input we have 3072. That's we already got it from the first we went here, no? So here we have the shape 32 into 32 into 3. The RGB, that's a 3, and 32 by 32 is a pixel shape that we are giving as an input. So this input is given simultaneous to everything, all the hidden layers together. Yeah. So it has to be 32 into 32 into 3, that number of inputs, and so here that will be 3072 inputs are there, and each will be connected to the, it's a densely connected, no? So each will be connected to the number of same number of neurons. So into 50. Does it make sense or? Yeah, hi. Yeah. Okay. So that's nice that I'm able to convey something. Now let's go to the next layer. Yeah. So next layer is having so we have the layer 2. In the layer 2, what is the input to layer 2? Yeah, here we have, this is a layer 2. How many inputs are there to the layer 2? This is a previous layer, no? Only 50 inputs, right? This layer 2 is having 40 neurons and the input is 50, right? 40 into 50, again 40 bias also. So 40 into 50 plus 40 into 50 plus 40, right? Yeah, nice. So we got the second where is this one? Yeah. So for 50 into 40 plus 40, we got 2040 parameters for the second layer. And again in the third layer we have 30 neurons. So that means previous input layer from will be 40 into 30 plus again 30 bias of this one. Yeah, then total it everything. So this number of parameters are the what is the total number of parameters in layer 1, layer 2, layer 3. So this is the answer. Everyone is clear on this? Yeah, exactly. Yeah, right. So this once you understand this, quite easy. Now the tricky part is, if a dropout layer is added with a value 0.5 after layer 2, what will be the change in the number of parameters? Now what is a dropout? Let's try to understand what is dropout. Here I have explained it a little bit more, but I think it's already understood. So let's go to. By dropout, we try to avoid overfitting in deep neural network. See, the issue with neural networks, deep neural network, is that is the overfitting issue. Because the reason is there is so many hidden layers, and the system will try to. What happens is, let me find. Okay, there is other one. System will try to find yeah, this one. Okay, overfitting. There is no underfitting in a deep neural network. Only overfitting is issue. Yeah. So if you see here, if there is only like in the machine learning, we have only one hidden layer, and if you try to make a this model, it will be like something like this, underfitting. And when you are using a deep neural network, it will learn all the noises in the system, and it will try to get into that, and when the real data is given, it will not. 1 second, someone has come. Hello. Yeah. Okay. So this underfitting thing, you guys know everyone about this, or everyone is aware of this underfitting and overfitting stuff? Okay. So what happens is, in the overfitting, there is so many neurons, so each one will learn something like this, and all the noise will also be taken into account. So in the optimal one, this is the curve, and these are the like outliers. It should not be taken into consideration. Let's have a look on this one. This is the reason why I asked Anjali to take. There is something called variance and bias issues. Let's go through. If you're interested, we can go through this one. Bias is a difference between the actual and the predicted. This is the predicted values, and this is the actual values. Is this understood? Bias is the difference between actual and predicted. This bias is different from the other bias, okay? But we are learning the neuron. Yeah. Yeah. So what is variance? Can you explain if you know about it? Actually, that is a confusion. There's a confusion. Yeah, Satish, you want to say something? Exactly, that's the point I was trying to convey. Yeah, what I learned from different YouTubes is this is the something which I want to discuss. See, here, in this scenario, the bias means the difference in the actual and predicted. Usually, we say variance is the actual and predicted difference, right? But in this bias variance trade-off stuff, we are using bias to denote the difference in the actual and the predicted. Whereas the variance stuff is how much the data is test data is differing in every test. So for this circles represent, for example, the center represents the actual data, and these diamonds are representing the predicted. So if you have a low bias and low variance, this diamonds is what is predicted in every test. Okay, so they are all near to each other. And low bias means there is a difference between the actual and predicted is very less. So in the center is the bullseye is the actual value, and there you can find the diamonds. The diamonds is the predicted values. So all the diamonds are in the bullseye. That means low variance and low bias. Is that clear? Or exactly, yeah, that's called the low bias and low variance part. So this is 4 parts. Now we have divided 4 things. So low variance, low bias means something like this. Now we will go to the high. Yeah, let's try. Yeah, low variance and high bias. So here low variance means the difference, the test result is always almost same only. I mean, there's no much difference in the test results, but it's always different from the predicted. I mean the actual. The predicted is actually is here in the bullseye, and the predicted is somewhere here. But it's all the always the prediction, the test results are coming in this same group only. It's not scattered. This bias is different from what we learned in the neural network, that bias and the input weight and all. That's a different bias, and this is a different bias. So here the time the bias is used to denote the difference in the actual and predicted. Yeah, there's a different terms from, yeah. Yeah. We are not dumb, but yeah, okay. Okay, okay, you will, okay, fine, that's good. Let me just finish these two, and then we will have a discussion. Okay. High variance means and low bias. Okay, high variance and low bias. You can see the low bias means, again, this is the central, the bullseye is the actual, and this is the predicted. Okay, so predicted is nearby to the bullseye or the actual nearby, so there is a low bias. There's not much difference between the predicted and actual. High variance means every time the test comes, there's a difference in the values, and even if the values are near to this actual, but still it's scattered. So high variance means that the test results are having scattered values, and if you go to the high variance, high bias, it means it's nowhere near to the center or nowhere near to the actual, and also every time the test comes, it's a different positions. So there's a high variance in the test results. Now I will just stop here. You guys can have a 1 minute of discussion. I will just take some water and come. Okay. Yeah, please start the discussion. Yeah, Praveena, yeah. Yeah, hello. Yeah, I don't have. Yeah, why? Mm-hmm. Sorry. So that is having high bias, low variance, or high bias variance trade-off. It's having. Mhm. Okay. What about others? You do. What do you think about this? This I got from this code basics or something. Yeah. Because a different. I tried to find it from different YouTubes, and finally. Hmm. Variance. I don't have it here. High variance in that certificate. Yeah, bias is the error that calculates the difference between the average prediction of our model and the actual value that they are trying to predict. Yeah, that's okay. Is the difference between the predicted and actual model suffering from high bias? Okay, okay, and the variance can be dependent on model sensitivity fluctuations in that. Yeah, that's a different test. When you do, there will be a different output. That's the yeah, that's what we are discussing. No, that's exactly the same, right? Yeah, that yeah that variance will be high when the model, yeah, right, because the model is learning from each and every noise. Yeah, so the variance will be high. Yeah, and bias will be high if underfitted. Yeah, exactly. Yeah, right. Yeah. Okay, I think we can. This is a good one. Okay, so it's the same thing what we discussed. I think that's the same. Anyone has a, yeah. Yeah. Yeah, exactly. This is what I was going to come. Actually, that's the same thing we are going to discuss. Actually, this is what we are going to discuss. Yes. So let me just put it here. Okay. It took me so much time to understand this one. I went to some different YouTubes and and you know, this many people are saying doesn't say much about it. They are also confused. I don't know. Only this code basics they gave a clear explanation. let's okay, this we know. So this is the training set versus the test set error. Okay, so model complexity is increasing, then the training set will be learned from the the training set will be this is the issue, because it will learn from model will learn from the training set very well, but when test is applied it will show so much error, right? This is the part we need to understand for the dropout. To understand the dropout, we need to learn this one. So here we have the error. This side is error, and as Praveena said, this is the error, and I think that this one also will do. Yeah, this is the error, and this is the model complexity. So the more high the model complexity, in the deep neural network we have more complexity. That's for sure. No, everyone is clear about it, right? Because we have so many hidden layers. So when the complexity is high, what happens is, if you see, this is the error that is coming up. Okay, this is the generic error of the generalization error. So here after this time, see, what we are trying to find is a complexity, a particular level of complexity. It's the error is increasing. If we see the initially so initially we have underfitting error so high, and then because the model is not at all complex, and then as the complexity is increasing, the error comes down, and at a particular position it starts increasing, the error starts increasing. So the test error will be increased, but the training error will be less. So that's what you can see in the other slide. Here they have mentioned test set and the training set. In this, if the complexity is very high, the training set error will be very less, but when you give the test data, the error will be high. So at a particular complexity, this error is less. So to overcome this issue of the deep neural network, I guess everyone is understood this complexity issue, the error issue. So what they have done is they will just cut off some of the neurons during the testing phase. So for every iteration they cut off some neurons. So as per our question, there is 0.5. That means half of the neurons will be cut off in every stage. So then it will create it will become less complex. And in the next iteration, again randomly it will cut some other 50% of the neurons, and in that way it will learn, and then this variance issue will be solved. So that's called the dropout. So is the concept clear? I don't know what is decision tree. I forgot actually. Yeah. Okay. Okay, maybe you can take a session on that. I'll be interested to listen to that. If I wanted to learn, I couldn't learn that time. So here you can, if you see, it's clearly depicted using the dotted lines. So many dotted lines. These neurons are all cut off. They are all drop out. So in this particular iteration, all these neurons. But what happens is, in that after the test is done, because this model is getting tested for every iteration, there will be so many iterations, so many approach, right? So this model is built after all the approach, and when it's going to test it, all the neurons will be in place. So for the testing, there is no change in the number of parameters. So this question is simply a tricky question, and the answer is there is no change in the number of parameters if dropout is added. Is it clear? Yeah, that's the point. Like for every iteration, they remove a number of randomly. They select some neurons and they remove it, and then the percentage is given by this 0.5 here. So half of the neurons are avoided, and in the next iteration again some other half are removed. So it's those weights, other weights and everything is kept like that. The neurons are not working. So in this way it is keeping on learning. at a particular time there's only half the neurons that are active, and this keep on learning, and the weights and bias will be adjusted during each iteration. So finally all these neurons will be in place during the test. For the training, for the training only half, every iteration it will be a half, only for the training. During the training, and in the training it's not like one iteration, no? There will be thousands of iteration. They call it epoch or something, no? Epoch, that one. So there will be thousands of epoch, and maybe like half of epoch one, some neuron will be off, and during the other epoch the other neuron will be off, and it will be learning in the alternative way. So the complexity is reduced during each epoch. So this overfitting is due to complexity, right? So that way we have to understand it like an overview of this one. So that's about C. Now D is, I am little bit not clear about D. So D I am still working on question D, or if you can take up and answer it, it will be nice. What is the difference between the kernel regularizer and activity regularizer? So kernel regularizer is just to penalty on the anyway this bias and stuff, like bias and what you say, weight, bias and the weights, and there is an some value here also. I mean the output of this activation layer will have a particular kernel function, something that will also, there's 3 values are there. So these 3 values, it can grow actually when it's iterating and learning. It will grow if not controlled. Exactly, so so there is one more relation, I think the bias regularizer or something is there. So these 3 we need to have some idea on that. So for that I am trying to understand the overfitting underfitting thing, and then we will go into the regularizer, and then so I am trying to prepare some notes on this, but it's a bit tricky. So if you can take it up, it would be nice. Please, you are in the comment study group, no? You are in the combined study group, right? Announcement. So there is one combined study group where I am trying to post something in Naked. So there's sometimes some discussions happen, because in the DL group the people are not ready to discuss. They are in holiday mode now. So when I post something, everyone is criticizing. What you are. So I created one group for comment study. So let me. Okay. So this is all I have to. Discuss today. So let me just share this invite for comment study group. Okay, I will just put it in this chat. Sure, I will share it. Anyway, thanks for asking. Actually, nobody was asking last time. Okay, I will share it in the meet. Okay, it's showing here. Yeah, I put the chat, I mean the combined study chat, and this. Let me share this one also. Mm. Yeah, I have sent the document also, and the Praveena, you are able to join that? Okay, fine. Yeah. Yeah. So. Okay, fine. Yeah, that would be better. Yeah. 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 Sure. And keep in touch. It will be nice to have someone like you who can take up the session also. Okay. Sure. 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 Yeah. Okay. Anything else, guys? That's fine. Yeah. Today's session. Any feedback? How was it? Is it okay? Wonderful. Yeah. Yes. Wonderful. Yeah, do the studies and take a session on for us. Okay, then you will get 100. Mm. Because we will point out the errors you make. No? You already got for ISM.